Hey everyone, today we are setting up Jetset with Aximetry for some amazing virtual production. First things first, you're gonna download Jetset from the App Store. Next, go to the Lightcraft website and download Autoshot and Autoshot tools. Also download and install Aximetry and Unreal Engine 5.6 for later. Once everything is installed, let's open up Jetset and create a new project. Click on the settings icon, project, and make a new project. You can name it whatever you want. I'm naming it Axim Tutorial. Next to the name is the prefix. This helps a bunch when you have multiple projects and files. You'll always know which file belongs to which project just by looking at the prefix. Now jump over to Autoshot. The UI might seem confusing, but there's nothing to worry about. We only need to focus on the folder setup and sync sections for now. We need to make a project with the exact same name as our Jetset project. So click Browse and make a folder with that same name. By the way, you want both your iPhone and PC to be on the same network, so Autoshot can sync with Jetset. If you've done everything correctly, with Jetset open, you'll see the sync section automatically fill up with the right information. Now, with your project set up, we're going to calibrate the camera. For this, you're going to first need to mount your iPhone to the camera such that the phone camera and cine camera lenses are as close as they can be. Next, you need an Axim CMO. So Jetset can see what your cine camera is seeing. You can see how I've mounted everything. Back in Jetset, to begin calibrating, select the settings icon, recording, cine calibration, and new. An important thing is you don't want to calibrate on a green screen stage because we're looking for a lot of feature points that match our natural features, and a green screen doesn't have features. Now we click Start, set the frame delay. The default value should be fine, and we see a simultaneous feed of Jetset and our cine camera. The red dots are the feature points. Click Test Frame. We now want to go around a particular subject sort of in a semicircular path and take these test shots. A minimum of 8 shots are needed for calibration, so let's go ahead and do that. When you're done, click Save and give it a name. Now you'll see a red reticle on Jetset. We want to head back to Autoshot, this time going to the Calibration tab, where we can see that Jetset is being detected. It's important that we enter the camera sensor width here. I'm using a Blackmagic Pocket Cinema 6K, so it's 23.1 millimeters. Then we click Calibrate. Autoshot's going to crunch some numbers and give us a solve. Once that's done, you'll see the aiming reticule is now yellow on Jetset, which means that calibration is complete for the lens. Next, we want to click on Cine and generate Aximetry calibration. This will generate an XML file that'll come in handy later. Now we want to open the Jetset web page. That'll open a digital slate synced to the app. Head over to the Settings tab, where we want to set up our tracking protocol. Change it to AGTP, set it to this PC, and save. Take note of the tracking IP address and port. With that, we're done with setting Jetset up. Now to set up Aximetry, I've already set up a scene in vanilla Unreal Engine. We're going to open UE for Aximetry, browse, and find that project. It'll prompt us to make a copy since it's made of a different version of Unreal, so we're going to go ahead and do that. Once it's open, we're going to make some changes to the project settings. First, we go to Maps and Modes and change our default editor as well as Game Startup Map to the one we want in our Aximetry scene. Next, type Stencil in the search bar and change Custom Depth Stencil Pass to Enabled with Stencil. Finally, type Packaged into the search bar and under List of Maps to include in a packaged build, add the same map. With that done, we want to add an Aximetry camera to the scene. Click on Aximetry in the toolbar and you'll see different camera options. We're going to be focusing on the tracked camera. Note that the initial position of this camera in Unreal doesn't matter. When you load the level in Aximetry, it always starts at the world's origin point. You can only move the camera inside Composer. We're going to position the camera how we want the shot to look and note the transformation values. We'll use these values in Composer to match the camera position. You can now either cook the project or use it with Live Sync. Cooking takes some time, but it runs smoother and doesn't require Unreal to be running. If you have special elements that break in a cooked build, you'll have to use Live Sync. I'm going to cook the project. You can save and close Unreal once that's complete. Finally, we open Composer, where we'll be doing the bulk of the work. In the Startup configurator, drag your video input, click on Camera Tracking, drag C Tracking, click the drop-down, and select the same IP address as the Jetset web page and type in the port number. Finally, select the calibration profile and add the XML file we generated in AutoShot. With that, the initial setup is complete. Create a blank project, navigate to the File browser, go to Common Studio Camera, Tracked Cam Unreal, and drag in the first one, the Tracked Cam 3 camera comp. This allows us to have up to 3 cameras. Then drag in your Unreal for Aximetry project, let it load, and then connect the nodes as such, matching the pin names between the two. Finally, drag the preview and out pins to the side. You would have noticed that these tabs, the cameras and the inputs tabs, appeared after adding the tracked cam into the comp. These tabs are where we'll be spending most of the time. Go to the Input tab, select Input 1 settings, and you'll see all the options that can be edited on the right side. The camera and tracking devices will be mapped to the ones we set up earlier. Most of these values don't need to be changed unless necessary. The override options let you take over the virtual camera properties. The camera delay lets you adjust the camera feed in case the tracking is off. Same with the tracking delay. You also have the option to detect tracking delay, where it'll ask you to point the camera at a bright red target and pan the camera to calculate the delay. Timecode sync is applicable when you have a timecode generator keeping the tracking device and the camera in sync. The tracking de-jitter option tries to fix any jitter in the track when the camera is stationary. Onto the Monitor 1 settings, you have 4 view modes. Select Input, and you'll see the Input 1 automatically selected, and the preview updates to the camera input. Select Studio, and you'll see the green Studio box is selected, and you have its corresponding values on the right. Here you can map out your virtual studio to the physical one with absolute precision. Next, select Keyed, and the Keyer 1 gets highlighted. Here you can adjust key options. First, set the monitor mode to input, click on the background color, drag the eyedropper, and select a point in the preview window. Then, set the monitor mode to matte, and change the values of the low and high cut, so the black and white sections of the frame are perfectly distinct. Then you can set the monitor mode back to final and see your updated key. Lastly, select Final, and you'll see the preview update to the final compared image. The adjuster settings control the color values of your input. You can change the values here to better match your talent to the virtual environment. The scene settings have controls related to your virtual Unreal scene. The base cam transform controls the Aximetry camera we placed in Unreal earlier. The Use Billboards option uses image planes to better integrate your shot into the scene. Next to the scene, we have the billboard settings. Each input has 4 billboards. These billboards act differently based on the camera type. While using the tracked camera, make sure to measure the distance between the camera and the talent and place the billboard at that distance. I would suggest experimenting with the options here to get a better understanding. The shadow options allow you to fine-tune the shadows of your talent in the virtual scene. The lit option lights your talent using the virtual lighting in your scene. Under the scene settings, we have Origin. Here you can set up an origin point using an Aruko marker that can be found on the Aximetry documentation placed in your studio. If you don't have the Aruko marker, you can manually adjust the origin transforms. Let's move on to the Camera tab. Here you can select which camera is active and its virtual movement path. Each camera has 8 paths that can be saved. The preview monitor output allows you to see each camera's output without changing the actual output. That covers the basics of using Jetset and Aximetry for virtual production.